The universe you live in does not exist until you look at it, and the moment you look away, it dissolves. Not metaphorically, not philosophically, physically. What you see, what you measure, is holding reality together. And there is no shared world running quietly behind your back. Look at the surface in front of you. A desk, a screen, your own hand. The light hitting your retina right now is not reporting a finished world to you. It is completing one. Photons arrive, your rods and cones register them, and only in that instant does a definite fact come into existence. Turn your head. Everything behind you loses its definite state. Nothing collapsed, nothing broke. There was simply never anything back there with a value attached to it. Not until you turn around. You are not watching the universe. You are holding it together, one measurement at a time. This is where the wound opens. One photon, two slits. Fire a single particle of light at a barrier with two openings, just one. It cannot split, it has no parts. It arrives at the far screen as one dot in one place. Do it again, another dot, then 10,000 more, and a pattern assembles that should be impossible. Bright bands, dark bands, an interference pattern, the signature of a wave passing through both slits and interfering with itself. One indivisible particle, two paths, at once. Now do the cruel version. Put a detector at the slits. Ask which one it went through. The pattern dies, instantly, completely. Two bands, no wave, no interference. You did not touch the photon. You asked a question. The answer erased the wave. Physicists have a name for the wound this opens: the measurement problem. The mathematics of quantum mechanics has two rules that contradict each other. Rule 1. When nobody looks, systems evolve smoothly, deterministically, as spreading waves of possibility. Rule 2. When a measurement happens, one outcome appears and the rest vanish. The theory never says what a measurement is, not once. In 100 years, nobody has written down the equation that separates a measurement from any other physical process. There is no mass threshold, no size, no temperature, no line. Quantum mechanics is the most precisely tested theory in the history of science, and its central term is undefined. You are running on devices built with this theory: your phone, your screen, the laser reading your data off a disk somewhere. All of it engineered with equations nobody can fully interpret. You trust it because it works. It works because you keep asking it questions. Nobody can tell you what that means. A single photon, the smallest unit of light, has been asking us the same question for a century, and we keep refusing to hear the answer. In 1961, a Nobel laureate took the measurement problem and made it personal. Eugene Wigner, Hungarian-American physicist, one of the architects of quantum theory. He wrote a short essay containing a thought experiment so simple it fits in a sentence, and it has never been resolved. Picture a sealed laboratory. Inside it, Wigner's friend. She measures a photon. Two possible outcomes. She looks at her instrument and sees one of them. For her, the wave is gone. A fact now exists. She writes it down. Wigner is outside the door. He has not opened it. He has not been told anything. So he does what quantum mechanics tells him to do. He describes the entire sealed lab, the photon, the detector, the paper, and his friend, as one quantum system. Evolving smoothly. No measurement has occurred. No outcome exists. Hold both of those in your head at once. Inside the lab, the measurement happened. There is a fact. Outside the lab, the measurement has not happened. There is no fact. The friend herself is in superposition, spread across both outcomes, having seen both results and neither. These are not two descriptions of one reality. They are two incompatible realities. One says an event occurred. The other says nothing occurred at all. And there is no experiment you can run, no instrument you can build that tells you which one is correct. Because both are simply quantum mechanics applied correctly by two different people. Give this its proper name: the collapse of the single fact. Everything you believe about the world assumes that events happen, once, definitely, for everyone. Wigner's friend removes that assumption, and nothing in the mathematics puts it back. For 100 years, the finest minds in physics tried to close this wound. Watch each attempt fail. Copenhagen, Bohr and Heisenberg, the 1920s. The wave collapses when a measurement occurs. Ask what a measurement is, and you are told the apparatus is classical. Ask why the apparatus is classical when it is made of atoms, and you are told the question is not physics. This is the interpretation that trained 3 generations to shut up and calculate. It works. It predicts everything. And it defines nothing. It draws a line, the Heisenberg cut, between the quantum world and the classical one, and then refuses to say where the line is or what puts it there. Copenhagen does not solve Wigner's friend. It forbids you from asking. Many worlds. Hugh Everett, 1957. There is no collapse. Every outcome happens. The universe branches, and every branch is real, and every version of you continues in one of them. Elegant, mathematically clean. It removes the measurement problem by removing measurement entirely. But it multiplies reality without limit. Uncountable copies of every particle, every galaxy, every person, most of which you can never observe, test, or reach. And it still owes you an explanation of why you find yourself in this branch, and what probability could possibly mean when every outcome happens with certainty. Bohmian mechanics. David Bohm, 1952. Particles are real and have definite positions at all times. A pilot wave guides them. Nothing is uncertain. You are simply ignorant of the initial conditions. The mathematics is beautiful, and it reproduces every prediction exactly. The price is explicit non-locality. Every particle in the universe instantaneously informs every other. And the observer is stripped of any role at all, restored to a spectator watching machinery he cannot touch. 3 brilliant frameworks, radically different, and every one of them shares a single, unexamined assumption: that there is one world out there, objective, complete, sitting in a definite state whether or not anyone is looking. Every interpretation for a century has been an attempt to protect that assumption. None of them survive Wigner's friend intact. And notice what you did while listening to that. You assumed one of them must be right. You assumed the answer was somewhere in the list. That instinct is the assumption itself, operating on you in real time. What if the problem isn't quantum mechanics? What if the problem is the assumption that there's a single reality out there waiting to be measured? In the 1990s, 2 physicists asked a question so simple it was almost heretical. Christopher Fuchs, Carlton Caves. Working on quantum information, the mathematics of how quantum systems carry, store, and lose information. Not philosophy, engineering. And in that work, they kept hitting the same wall. The quantum state behaved less like a description of a thing and more like a description of what someone knows about a thing. Update your information and the state changes instantly, no matter how far away the system is. That is not how physical objects behave. That is exactly how knowledge behaves. So they asked it out loud. What if quantum mechanics isn't about the world at all? What if it's about you? To understand what they did next, you need a mathematician who died 230 years earlier. Thomas Bayes, English Presbyterian minister, a dissenter, outside the established church, outside the establishment. He wrote an essay on probability and never published it. He died in 1761. 2 years later, a friend read it to the Royal Society. His idea inverted the entire subject. Probability, Bayes argued, is not a property of the world. A coin does not carry a 50% inside it. Probability is a property of you, the degree of belief you hold given the evidence you have. New evidence arrives, you update. That is all probability ever was. The idea sat dormant for 2 centuries, then it consumed statistics. Then it built modern machine learning. Every system that learns from data is running Bayes' rule underneath. And then Fuchs and Caves, later joined by Rudiger-Schack, pointed it at the deepest object in physics. What if the quantum state is a Bayesian probability? The name came later. Quantum Bayesianism, compressed to QBism. And it did something no other interpretation had attempted. It did not change the physics. It changed the observer. The wave function. Sigh. The object physicists treat as the most fundamental thing in existence, the complete description of a quantum system from which every prediction flows. QBism tells you something about it that is difficult to absorb. It is not out there. It is in here. The wave function is your personal degree of belief about what will happen when you make a measurement. Not a substance, not a field, not a cloud sitting around a particle. A catalog of your expectations, written in the most precise language ever invented for expectations. It is a betting strategy. That is not a slight. It is the strongest possible statement. It encodes exactly what you are entitled to expect, given everything you know, and it does so with a precision no other framework in science approaches. But it encodes your uncertainty, not the world's. And this dissolves an old confusion immediately. When you measure one half of an entangled pair, the state of the distant half changes instantly, faster than light, across any distance. Physicists have agonized over this for 90 years. QBism's answer is flat. Nothing traveled. Your information changed, so your betting strategy changed. Nothing crossed the room because there was never anything out there to cross it. The wave function, the most fundamental object in physics, exists only in your mind. There is no wave function without you. Without an agent asking a question, there is only nothing. When you measure a quantum system, you are not discovering a pre-existing fact, you are creating one. Think about what a measurement actually is. You act on the world acts back. An outcome appears in your experience, in your instrument, in your life. That outcome did not exist before you acted. It is not a fact you uncovered. It is a fact you brought into being by intervening. The photon did not have a position before you looked. It did not have a path. Not a hidden one, not an unknown one. There was no fact of the matter waiting to be found. Your question created the answer. Understand precisely what QBism is claiming, because this is where every popular account goes wrong. This is not mind over matter. You cannot choose the outcome. You cannot think a particle into a location. The world pushes back, hard, and it pushes back in ways you cannot control. That resistance is the clearest evidence you have that you are not alone in it. What you control is the question. The world supplies the answer. And the answer does not exist until the question is asked. Give this its name: the participatory act. Every measurement is an intervention that changes both parties. You reach into the world. Something genuinely new comes into existence, new for the world, new for you. And your belief updates, from a spread of possibilities to a single lived fact. That new belief is your reality, not a picture of it, not a report about it. For you, that is what real means. This is not mysticism. It is Bayesian updating, applied to quantum states, with the mathematics unchanged. The Born rule, the most important equation in quantum mechanics, is not a law of physics. It's a law of thought. The universe follows it because you follow it, because you are rational. And reality itself bends to your rationality. Max Born, 1926. A footnote added while a paper was already in proof. Take the wavefunction, square its magnitude. That number is the probability of each outcome. Psi squared. It is the bridge between the mathematics and every experiment ever performed, and it has never once failed. Everyone treats it as a law of nature, a rule the universe obeys. QBism reinterprets it, and the reinterpretation is surgical. The Born rule is not descriptive. It is normative. It does not tell the universe how to behave. It tells you how to behave. How a rational agent should adjust one set of beliefs to stay consistent with another. It sits in the same category as the ordinary rules of probability, an addition to them for a world that contains quantum measurements. And there is a hard argument behind that claim. The Dutch book. Here is what it says. Your probabilities are the odds at which you would accept a bet. If your assigned probabilities violate the rules of coherence, then a clever opponent can construct a set of bets, each one you accept as fair, that you are guaranteed to lose. Every time. Not likely to lose. Certain to. That is not a physical penalty. It is a logical one. Incoherent beliefs are self-defeating on their own terms. QBism's claim is that the Born rule is exactly this kind of constraint. Violate it, and you are not contradicting an experiment. You are contradicting yourself. The universe appears to follow the Born rule because you follow the Born rule. Because you are an agent navigating uncertainty, and this is what coherent navigation requires. Sit with the inversion. You were taught that the equation governs the particle. It governs you. The particle was never reading it. You were. You are already arguing with this. Good. Take the three strongest objections in order. 1. So reality is subjective. No. QBism rejects the entire subjective-objective binary you are reaching for. That binary assumes there exists a view from nowhere, a description of the world written by no one, from no position, using no instruments. There is no such description. There never has been. Every equation you have ever seen was written by an agent, standing somewhere, using something. Science is not the absence of a perspective. It is the most disciplined perspective ever constructed. Calling that subjective is not a criticism. It is an observation about what knowledge is. 2. But we all see the same moon. Do you? You and I see correlated experiences of a moon. Intersubjectivity. We agree because we are similar agents, similar biology, similar instruments, similar histories, standing on the same planet under similar light. Agreement between similar systems is exactly what you would predict. It is not evidence of an observer-independent world. It is evidence that we are alike. Two calibrated thermometers in the same room agree. That agreement tells you about the thermometers. 3. Then why does the world persist when nobody is watching? Because you never stop watching. Your measurement of the world is continuous. Every second of waking life is a dense, unbroken stream of interventions and outcomes. The room does not need to be held together by an absent observer. It is held together by you, constantly, and by everyone else constantly in their own worlds. There is no third thing required. No backstage reality maintaining continuity while nobody checks. The demand for one is a habit, not a finding. Now count what this costs and what it buys. The measurement problem dissolves. Not solved, dissolved. There is no mystery about when a wave collapses, because nothing physical collapses. An agent updates a belief. That is what a measurement is. It requires no new physics, because it was never a physical process. Wigner's friend stops being a paradox. Two agents, two experiences, two belief states. The friend had an outcome. Wigner had not. Both are correct. There was never a single fact for them to disagree about, so there is nothing to reconcile. And look at what QBism does not need. No parallel universes, no hidden variables, no collapse postulate bolted onto the equations, no Heisenberg cut dividing the quantum from the classical, because there is no division. Quantum theory applies to everything, and an agent can use it on anything, including another agent. It is consistent with every experiment ever performed. It has to be. It changes nothing in the mathematics. Every prediction quantum mechanics makes, QBism makes identically, because it is the same theory read correctly. It is the only interpretation that pays for the measurement problem by giving something up instead of adding something on. And it puts you at the center. Not you flattered. You implicated. You were never the audience for this theory. You were always its subject. This is where Fuchs takes it, and it is the most radical claim in the theory. There is no God's eye view, no master description, no way things really are, independent of anyone. There is your world, continuously created by your measurements, your interventions, your experience. And the person sitting next to you? They are not in your world. They are in theirs. Correlated with yours because you share biology, instruments, language, history. Correlated, never identical. The person sitting next to you lives in a different universe, and they have no idea. Neither did you, until now. Here is the anti-promise. QBism predicts no new experiment, and that is not the point. You want a theory that makes a novel prediction so you can test it and settle this. QBism will not give you one because quantum mechanics already works. Every prediction is already correct. There is nothing left to predict. What QBism reinterprets is data you already have. So look at where the other interpretations break and watch what happens there. 2018. Czeslaw Bruckner takes Wigner's friend and extends it. Two sealed labs, two friends, two outside observers. Entanglement between them. He derives a Bell-type inequality and shows that if you assume observed facts are absolute, shared by all observers, the assumption is inconsistent with quantum mechanics. Facts, on that analysis, exist only relative to an observer. The same year, Daniela Frauchiger and Frauchiger-Renner publish an argument with a title that reads like a verdict. Quantum theory cannot consistently describe the use of itself. Multiple agents reasoning about each other's reasoning, using quantum mechanics correctly, and arriving at flatly contradictory conclusions about the same experiment. Then it left the page. Proof-of-principle experiments with photons standing in as observers have violated these inequalities in the laboratory. Not a thought experiment anymore. Every one of these results is aimed at the same target, the assumption that observed events are absolute, that what happened, happened for everybody. The no-go theorems do not touch QBism. They cannot. QBism never made that assumption. Notice what has happened here. QBism adds nothing to quantum mechanics. No extra worlds, no extra particles, no extra equations. It is subtraction. It removes one assumption, that there is a world out there, complete and definite, independent of you. One assumption, removed, and everything else follows. Understand what you are looking at. This is not philosophy. Philosophy does not have 100 years of laboratory confirmation behind it. This is quantum mechanics, the most tested theory in the history of science, verified to more decimal places than any other statement humans have made about nature. Interpreted as a theory of experience. Not a theory of particles, a theory of what happens when an agent reaches into the world and something answers. If QBism is right, the physics does not change. Every prediction stands. Every device still works. Only your position in it changes, and that changes everything you thought you knew about being here. You came into this expecting a fact about particles. What you are being handed is a fact about you. If QBism is right, everything you assumed about reality, that it is shared, that it is finished, that it waits for you, was wrong. Not slightly wrong, structurally wrong. You are not a passive observer of a pre-existing universe. You are an active participant. Every glance, every question, every measurement, you are building your world, one observation at a time, and nobody else can see the one you're building. Follow it where it goes. There is no view from nowhere, no God's eye perspective, no way things really are. You have carried that assumption since before you could speak. Somewhere, there is a complete and final account of what happened, the real version, the one that would be true even with nobody left to read it. Every argument you have ever had about facts assumed that account exists. It does not. There is your world, continuously created by your measurements. There is theirs, continuously created by theirs. There is no third account arbitrating between you. Which means, when you and another person disagree about what is real, you are not both looking at one object from different angles. You are reporting from two different universes. And the correlation between them is high and imperfect, and it is all you will ever have. If QBism is right, your death is not only your end, it is the end of a universe. Yours. The one that existed only through your measurements, your questions, your experience. Every fact in it was created by you asking. When you stop asking, the facts stop being created. Not hidden, not archived, not continuing without you. Stopped. And there is no backup, no master copy sitting in some registry of what really happened, waiting for you to stop looking so it can carry on unobserved. There never was one. Other universes continue, billions of them, every one of them missing the one thing yours had, the view from inside it. You are not one observer in a shared cosmos. You are the observer of your cosmos. And when you're gone, that cosmos goes with you. There is no one else who sees exactly what you see. There never will be. You have a word for this by now. Solipsism. The belief that only you exist, that everyone else is an illusion running in your head. QBism is the exact opposite. And that difference is the most important thing you will take from any of this. Solipsism says, I am the only real mind. Every other person is furniture. QBism says, every mind is real, every single one, each an agent, each a center, each creating a world through their own measurements, with exactly as much standing as you have. There is a principle underneath this. Call it the quantum Copernican principle. No user of quantum theory is privileged. When two agents interact, each is a physical system in the other's account. There is no master observer. Fuchs has been explicit about this. He calls the position participatory realism, and he means realism. The world is real. It is not made of your thoughts. It resists you, surprises you, refuses you. You are not alone. You are one of billions of centers, each generating a universe, all of them correlated by shared biology and shared instruments and shared light, which leaves you with something harder than loneliness. The person you love most in the world inhabits a universe you can never enter. Not because they hide it, because there is no door. You will never see the inside of their world. Only the correlations, only the reports, only the outside. And they will never see yours. That is not isolation. That is the deepest possible reason to take another person's experience seriously. Their world is not a flawed copy of yours to be corrected. It is a universe, entire, with its own center. And if your measurements create your reality, then what you choose to observe is not a small thing. Your attention is not passive, it is generative. Every question you ask brings a fact into existence that did not exist before you asked it. Every question you decline to ask leaves a region of your world permanently undetermined. The experiments you run, the literal ones, and every metaphorical one, every conversation you start, every place you look, constitute what is real for you. You have been treating your attention as a limited resource to be spent. It is not. It is the instrument that builds the world you live in. You are not a victim of reality. You are its author. There is one question QBism leaves you with. It is very short. And once you have heard it, you will not stop asking it. When you close your eyes, where does your universe go? For 100 years, physics has been trying to explain how reality works out there. It built parallel universes to do it. Infinite branching worlds, unobservable by construction. It built hidden variables and non-local pilot waves. It built objective collapse mechanisms, new physics invented for the single purpose of making outcomes definite without anyone present to see them. All of it engineering. All of it in the service of one goal: removing the observer from the equation. QBism suggests something simpler and considerably worse. There is no out there. There is only here. There is only now. There is only you. And the universe you are assembling with every breath, every glance, every question you decide to ask. You wanted the universe to be the large thing, and you the small thing inside it. Reverse it. You do not sit inside the world. The world assembles at the edge of your questions, and nowhere else. You do not live in a universe. You are a universe, a private one, continuously created, never duplicated, and one that nobody else will ever see from the inside. And that is what it means to exist. If this changed how you see the world, send it to someone who needs to see it too. Not because it will entertain them, because their universe, the one they are building right now, without knowing they are building it, might need this question in it. One thing before you go. Do this tomorrow. Watch yourself observe. Catch the moment you assume something is objectively true, a fact, a measurement, a reality you did not question, because it did not occur to you that it could be questioned. And then ask, is this out there, or did I create it by asking? The answer will not be comfortable, but it will be yours. Send this to a friend whose reality you want to change.